Hello. So sorry, this last video got cut off. This is structural analysis made fun and easy. A single span beam with two small cantilevers. So this is about loading, bending moments and stresses. Please like and subscribe to the channel. So we got to this point where we had found the reactions RA and RB. RA equals 3W, RB equals 3W. That's obvious really when you think about it because of the symmetry of the beam. The internal span is 4 meters plus 1 meter on each end, so the total length is 6W. So RA, I did moments about A in the last video. So now we need to know what the maximum bending moments are. So we can see I've done the bending moment diagram now. I know from experience that I'm going to get a curving moment in the middle of the beam, and I reckon it's going to be maximum at the midspan, so I've drawn that in. But if you don't know it, you would just say working from the left hand, one of the ends, or you could just say I'm going to take sections about the middle of the beam to find out what the moment is in the middle, or take sections about any point until you find the maximum moment, and you would find that it's in the middle. So what I do to find the maximum moments, I'm going to take sections by taking moments about the midspan to the left hand side of the beam. So just say in the middle, and take moments about this side. So if I take moments about the middle, I get the moment of the middle is minus 2 RA, because this half of the internal span is 4 over 2 is 2 times RA, and then I get plus 3 meters times W times the lever arm for the W, which is 3 over 2, because the loaded width between the middle and the end, that's 3 meters. So the equivalent point load would be at 1.5. So that gives me minus 2 times 3W plus 3 times 3, which is 9W over 2. That gives me 6W plus 4.5W. That's the moment at the middle, and that's minus 1.5W. So I know that the sagging moment maximum is 1.5W kilonewton meters. So I can check this easily by taking moments about the other side. So taking sections about the other side. Because it's symmetrical, it's obviously going to give me the same answer. So if we want to do another check, is there any other way we can check this result by hand? So we can say that, let's just imagine that the beam was simply supported without moments at the ends. So then the moment in the middle would obviously be WR squared over 8, which would be W times 2 times 2. Sorry, W times 4 times 4 divided by 8, which is W times 16 over 8, which is 2W. So, but in this case, we've got the tension moment across the entire length of the beam, because we got cantilever moment at the end, cantilever moment at A, at RA, and cantilever moment at B. So that across the whole length is equal to W over 2. So if we did W over 2 and then we add the maximum moment for the simply supported case, which is WL squared over 8, which we just worked out was 2W, then we'd have the moment would be W2 and then 2W down, and that would give us minus 1.5W. And since we got all those checks, we've done three ways of working out. We take our sections to the left, sections to the right, and then we've done this just common sense check. Then we can see that actually the moment is 1.5W. So that means that we found the maximum moment hogging at the support, and we found the maximum moment sagging in the middle of the beam. So that really, now we know where the maximum moments are. We can try and find the maximum stresses due to bending. So this is just a summary diagram. the highest stress is induced in the section is where the highest bending moments occur. So we've got the maximum hogging moment at the support, which is 0.5W. So that means it's going to try and create tension at the top. We've got a hogging moment, it's going to go this way, going to create tension at the top. So where I've drawn the orange, that's going to be in tension, and the beam section, the bottom of the beam, is going to be in compression. Oh yeah. So basically, the question says that the section, this is the section AA. Here, it is. We've got a section which is basically a U shape. So what I'll do in the next video, I'll just go over that. But we've got the maximum hogging at the is at the support moment 0.5W, and the maximum sagging is a middle 1.5. So we're going to get tension on the bottom. In the middle, we get tension in the bottom, compression in the top of the section. At the support, we get tension in the bottom and compression. Sorry, we get tension in the top. Sorry, I'll start that again. We'll have maximum hogging at the support. That means the maximum tension at the top of the section at support. So tension at the top at the support, compression at the bottom at the support. And we've got maximum sagging at midspan. We've got maximum compression at the top, maximum tension at the bottom. So basically, it's just inversing at the support. It's going to try and snap it at the top, and at the middle, it's going to try and snap it at the bottom. So it's reversing the stresses. So please look at part 3 for the completion of this problem. Thanks for watching. Please like and subscribe the channel.